Hey, Algebra 2, so we are back with lesson 3 and 4 today. Because like I told you, after that lesson 2 biggie, then the next 4 are actually pretty fast. Okay, so we're gonna do 3 and 4 today, 5 and 6 tomorrow, and then finish out the week, I believe, right? Okay, so look at 3.1, it says evaluate this. So what you need to do is you need to plug in -2 for x and -4 for y. My biggest consejo on this one is use parentheses. Use parentheses, please, okay? And also you can go ahead and like do squaring like in your head, right? So if you have x squared is -2, so it's gonna be -2 squared, that's gonna be 4. Okay, now if you were to write it out, because you like to do that or whatever, so you don't get confused, you need to put that in parentheses. -2 to the 2. Because if not, then it's all, if you don't put it into parentheses, you guys, when you go back to do that part of the problem, it's going to be -4, not +4, so you're going to get it wrong. Boom, right out, right like that. Okay, so here we go. We have 4 times -4, that's y, minus a -4. Another reason why it's good to have parentheses. So you can do the plus now. So now you're going to have -16 plus 4, so your answer is going to be a -12. That is example 1, okay? Same thing with example 2, because you have -2 and -4, -2 for A, B, 4 for B. So here we go, let's do this. We have a -4 minus a -2 minus a -2 times a 4, right? That was a horrible parenthesis, sorry. So you got -2 times, it's going to be positive, so that will be -2, minus, -2 times 4 is -8, okay? Then keep going, -2 times -2 is 4, and then minus a -8 is going to be +8, so your answer will be 12. So there you go. That's how you do examples 1 and 2. Okay, example 3.3 just says simplify by adding like terms. So you can only combine the ones that have the terms that are the same. So when I write this in my notebook, when I'm going to do this problem, I write it switching the like terms to have all your terms in alphabetical order. So like when I would write this in my book, I wouldn't put it as yx, I would put it as xy, because that's going to help you find your like terms easier, right? So you need to find your like terms first. So you have this one's a like term and this one's a like term, right? You have a -6, so be careful with that. So you have 3xy and -6xy, so you have a -3xy. Okay, those are gone. Then you have a -2x and a positive 3x, so you have an x. And then you've got your 4 left. So that should be your answer, -3xy plus x plus 4. The other thing to do, guys, if you want to make sure that you're not missing your negatives, and sometimes it's an easy thing for you to do, then just go, when you're writing it, also do plus a minus, then you won't miss that it's a negative with that subtraction in front of it. Okay, now this one right here, you need to put everything into the numerator so you can see what is alike and what is not alike, okay? Because this whole like numerator, denominator thing, you're not going to be able to see anything whether it's alike or not. So this is example 4. So here we go. We have 3a -2, b, c -1. Put it in alphabetical order as well. So then you have 4a to the -2, because you have to bring that one up. b, c to the -1. Okay. Then plus 7a squared, b, c to the -1. Put it in alphabetical order. And then minus, can you still see? Yes. 4a b squared c to the -1. Okay, so be careful because they're trying to trick you and like see how closely you're paying attention. Which one has a squared b c -1? We have 1 of these, 2 of these, 3 of these, and that's usually how Saxon goes. He does like 3 of them to make you think that all of them are like that, but they're not. Let's do a plus and negative right here. So you have 3 and a -4 is -1, -1 plus 7 is 6, a -2, b, c, -1, minus 4a, b squared, c, -1. In the book, they have it with denominators We don't care. Remember, there's 3 forms to do it, and if they don't tell you what form they want, then you can keep it however you want. So there is your answer, because you can only combine, there you go, so you can see it. You can only combine what is alike. Okay, lesson 4 is, at the very beginning, is about the distributive property. So look at example 1. It says to expand. That means that you need to take this term right here and multiply it by this, and then multiply it by this, right? Because you are distributing this into both of these to multiply them. So if you need a visual, just draw lines to it so you don't forget, right? Right now it's like no big deal, but sometimes that helps in other ones. Okay, so let's do it. We have 4a squared b to the negative 2, because we're just combining these two together because there's no like terms. And then you have a4b, because I'm just writing them in alphabetical order, minus 12 a to the what now? This is an invisible 1, so that's a to the 3 b over a squared b. Okay, there's one other step that you have to make sure that you do, which, what do you think that is? Combine all these a's and all these b's, all these a's and all these b's, okay? So there's 2 ways that you can do that. You can write them all on the numerator line like we used to do, or you can also just subtract 2 minus 4, negative 2 minus 1, right? Because you're subtracting these down here because they're on the numerator. 3 minus 2 and 1 minus 1. This one just cancels itself out, okay? So that's what I'm gonna do instead of writing all that over. So we go 4a squared minus, so 2 minus 4, a to the negative 2. Negative 2 minus 1. Negative 2 minus 1 is gonna be negative 3, okay? My only warning to you is if you do that and you don't write it out, you could get your negatives mixed up, so be very, very careful, okay? Over here, you have negative 12. 3 minus 2 is just a to the 1, and then b is canceled out. Okay, we check our answer, we make sure that we're right, and yes, we are, because it did not tell us that we had to put those in the denominator, so you can keep those there. Okay, let's move on to examples. Okay guys, what you're going to start to see too in algebra is that the algebra 2 book sometimes is just a longer version of the algebra 1 book, right? So you might have had stuff like this in the algebra 1, but now it's just longer and it looks scarier. But it's the same stuff. Saxon just wants to make sure that you are confident in the concepts that you know, okay? So look, we're going to have to multiply this one, this to this, and this to this, right? What I'm going to do right off the very beginning is I'm going to take this out, you guys. See how that's b to the 0? B to the 0 equals 1. Okay, and so actually this like kind of disappears because if we put a 1 here, right, representing b to the 0, it's invisible. So you might as well take it out. And the reason why I took it out was because it's just unnecessary for it to be there. It just gives us one extra step of looking at it every time we need to multiply. Okay, so here we go. We have a. Negative 3 plus 2 is going to give you a negative 1. B, C, over C cubed, right? Okay, then you have minus 3, a to the negative 5, over b to the negative 2, c. Okay, now we need to combine everything. A to the negative 1, b, c to the 1 minus 3. So that's going to be c to the negative 2, right? Minus 3, nothing to combine here. So I'm just going to put it all in the numerator because I already did up there on the other side. And that's your answer, okay? You do have to be careful if you're going to put like this all in the numerator and keep this in the denominator. That's fine, as long as you make sure that there's no possibility that those are like terms. Like if you leave stuff on the denominator and then it actually matches up to this in the numerator, then you're gonna need to combine these for like terms, but this one's not even close to like terms. So that's our answer. We check it, yep, and we're good to go. They just have it in a different form. Okay, basically the rest of the examples in this lesson are just review of what you've done before. Like I said, maybe look a little scarier, but basically the same thing. So here we go. Let's distribute everything we need to get rid of these parentheses, okay? Because all it says in the instructions is solve. So here we go, 12 minus 2x minus 5. Make sure you distribute this negative to both. Okay, you can't just do negative 2x plus 5. No. Negative 2, negative 5 equals negative 2 plus x minus 3. That parentheses wasn't doing nothing there. Okay, here we go. 12 minus 5 is 7 minus 2x equals negative 3 and negative 2 are going to be negative 5 plus x. Okay? Combine your x's, combine your normal numbers. So we'll bring plus 2x over here and plus 5 over here. Okay, to get rid of this and to get rid of this. So we have 12 equals 3x. Divide by 3, divide by 3, x equals 4. Okay, how do we make sure that we're right? We'll put it in. Let's put it into this one because we might have made a mistake here. So here we go. Let me do another color so we can check it. 12 minus 4 times 2 is 8 plus 5 equals negative 2 plus 4 minus 3. Okay, so we have 12 minus 13, that's negative 1. Negative 2 plus 1 is negative 1. So yep, it checks out. Okay, there is our answer. I will admit that this one does not look fun at all, but actually in the end, it turns out like really cute because all those fractions go away. It doesn't look fun because I don't like fractions really. But I just made a mistake, so I had to make this video over, so I already know like it ends really cute and comes together. That's nice, so don't worry. Besides, we can do problems that we don't like. We're strong. Okay, 3 times 5, 6. Look what you can do. You can cancel, right? Because remember, this is 3 over 1, so 3 times 5 over 6 is going to be, cancel out your 3 and the 6, and it becomes 2, so it's 5 over 2, right? Same thing over here, 3 times negative 5 thirds, well, you can cancel out the 3 and the 3, so it's 1, and you're left with negative 5x. If you're like, what did you just do, Jessica? I can't see all that right there. I can't visualize that in my mind. That's fine, then write it out. 3 times 5 6 is 15 over 6. 3 times negative 5 thirds is negative 15 over 3, and then you have to reduce later on, but that's whatever you want to do. Negative and negative is going to be a positive 1/2, and then make sure you distribute this negative over here. It is super easy to miss that negative, you guys, and a lot of people don't distribute it like they should, and that's how you get your answer incorrect. Okay, so now you're gonna move your 5x over here and your negative 1/2 over here. And see how cute it is turning out because there's not a bunch of like common denominators and stuff like that. So 5 over 2 minus 1/2 is gonna give you 4 over 2, which is just gonna give you 2. So 2 equals negative 1 plus 5 is 4. Okay, I'm going to show you another common error. You're going to see that this is 2 equals 4x. What do you think the answer is? Boom, you always think the answer is 2. Because 4 divided by 2 is 2. But, and look carefully, I'm going to try to move this down a little bit. You have to divide over here, the 4. So your answer is not 2, your answer is what? 1/2. Okay, be careful with that, 2 over 4. So you reduce it down to 1/2. This is where it gets fun, because you need to check it. And yes, you need to check it. You should not get these wrong. Told you before, there's ones with the x's in it. You shouldn't get it wrong because you can check them like this. Times 1/2, right? Equals negative 1/2 plus 1/2. Okay. So let's go over here. We have 3 times 5 6 minus 5 6. Oh my, okay, cute. Look, this is going to be 0. And 0 times 3 is 0. Equals negative 1/2 plus positive 1/2 is 0 too. So that's 0. It checks out just fine and easy. It checked out a lot easier than it looked like it would. Okay, cool.